Hello! So today we're talking about a continuation of what we talked about on Monday with box and whisker plots and quartiles. So hopefully today can sort out any misconceptions or confusions you might have had on Monday, but as always, if something doesn't make sense, it's always a good idea to ask for help. But today we're talking about interpreting box and whisker plots. And this presentation follows the same template for what your assignment looks like. So what I fill out in the notes is what you're probably going to be filling out in your assignment. So we're having to use box and whisker plots today to find information that is given to us. So if we have this box and whisker plot that tells us how many hours of television is watched, it goes from 0 to 6 hours. If it tells us to find our least value, I'm going to double click in there. It'll let me type. The least value that I see on this box and whisker plot is going to be represented by this, the whisker over here. The whisker right here shows me the very least value in this data set, which is 0. So that's what I would type in right here. I'm going to type in 0. Let me get my pointer. 0. That's my least value. My greatest value is going to be on the opposite side, the farthest whisker to the right. That's going to be my greatest value right there. My greatest value is going to be 6. If I'm looking at quartiles, I'm looking at this region right here, this box. The box in the box and whisker plot represents the quartiles. Okay, so on the farthest left side, on the farthest left side, not sure why it's being weird, but it's fine. This is my Q1. Q1. The line in the middle is the median, and that's Q2. The farthest outside right side of the box is Q3. Okay, so that's what we learned on Monday, how to make the box and whisker plot with the information of Q1, the median, which is Q2, and Q3. So my first quartile, if I go back in and type, my first quartile is Q1. So that's wherever this lies, which is at about 2.5. So the value for the first quartile is 2.5. Value for the third quartile, which is outside over here, is 5. And even though it's not in that order, the median, which is Q2, is at about 4. Median is Q2. Median is Q2. Median is Q2. Getting that in your head. Okay, so then if I want to find the IQR, I'm going to skip around here. IQR is the interquartile range. So the range within the quartiles. So how far is it from Q3 to Q1? To find that out, I'm going to subtract them. I'm going to take 5, which was Q3, minus my Q1, which is 2.5. Whoops, 2.5. And when I do that subtraction, I get that it's 2.5. That's the interquartile range. So my IQR, 2.5. And my range in general, so the IQR is the interquartile range, the range within the quartiles. The range, if it just says range, we're talking about the whole data set. So how far is it from the least value to the greatest value? I'm just going to erase this, get rid of some of that noise. So from the biggest value, which is 6, to my smallest value, which is 0, that means the data ranges over 6. Over 6 hours specifically. Okay, so that's it. We use the box and whisker plot to find this information. So then another thing you might be asked to do is to use box and whisker plots to determine other things. So first question we have here is to find the range. We know that it's not asking for the IQR. The IQR question is down here. It just wants the regular range. So I want to look not necessarily at how far the number line goes. I want to use the whiskers on the box and whisker plot to tell me what numbers to use. So my biggest value is about, I don't know, let's say about 83. And if you guesstimate that's okay because it's not going to be perfect. 83, if you want to say 82.5, it's up to you. So we're talking about life expectancy here. So the biggest life expectancy in whatever country this is 83 years old. The smallest life expectancy is at about here, right about at halfway. I'm going to call that 47. Okay, so I want to use the box and whiskers, not the number line. I don't want to do 85 minus 45. I want to do 83 minus 47. That'll tell me my range, which is going to be 36 if I subtract those to find my range. So 83, it'll let me 83 minus my 47, and that gives me a range of 36. So then another thing that we kind of hinted at yet in Monday's notes was that the quartiles split up my data. Quartiles, quarters make up 25 cents in a dollar, 25%. So my quartiles are going to split up my data into a certain amount of percentages. So let me get some labels going. So my Q1, right, is at the end of the box right here. That's my Q1. My Q2 is right here in the median. Okay. And then my Q3 is the far right side of the box right here. Okay. And if you're looking at this, those three different colored lines split up all of our data into 4 regions. And even though they don't look equal, the way quartiles work, they actually split up the data equally. So over here, I have 25% of the data. That's the first quartile, right? First quarter. Right here, I have another 25%. That's another quarter. Here is another 25% of the data, another quarter. And here's another 25% of the data, another quarter. So quartiles help us to split up our data so that we have an equal 25% chunk. It doesn't look equal, but they work to help us represent the data that way. So if I go to answer these questions, it says what percent of the life expectancies are between 47 and 65 years. Okay, well, 47 is about right here, right? And 65 is right where quartile 1 starts. And like I said, it doesn't look even, but it is exactly from there to there. That is 25% because that's a quarter. It's a quartile, 25%. So that's what I'm going to write here. That there's 25% of the data right there. Then it asks me for 65 up to 80. And 65 is right here, 80 is over here. And remember, this is 1 quarter right there from Q1 to Q2. Q2 to Q3 is another quarter. So if it wants us to go from here all the way to here, this is 50% of the data. There are 2 quarters right there. So that's what I'm going to write. 50% of the data is from 65 to 80 years old. So most people will have a life expectancy of 65 to 80. They will live to be 65 or 80 years old for most people. Over here, it asks me from 80 to 82, which is this little tiny chunk right here. And that's another quarter. That's my 4th quarter. So that's just another 25. And oops, I need to keep it here. So, and if you notice, all of these, 47 was the smallest number, right, on my data. And 82 was the biggest number in my data. And notice that all of these add up to be 100. This represents 100% of everything, okay? But the quarters split it up into 25% chunks. We just have to interpret what that means exactly, okay? So I'll write right here, this is 25%. It lets me 25. This one was 25. And this teeny weeny chunk was also 25. The quartiles, quarters, 25%, okay? So then if I want to find the IQR, the interquartile range, I'm going to take, let me do some erasing here. I'm going to take the biggest value for my box because that represents the quartiles. The biggest value was 80, and I'm going to see how far away that is from 65. So I'm going to do 80 minus 65, and that's going to be my interquartile range. 80 minus 65, which is equal to 15. That's my interquartile range. So the middle 50% of all the data is spread out over 15 years. Okay. The last question asks me, is the data more spread out below Q1 or above Q3? So let's see where that is. Below Q1 is everything from Q1 this way to the very end of the whisker. And everything above Q3 is everything this way of the whisker to the heading to the right. So everything all the way to the end that way. That's above Q3. Above Q3 is from the end of the box to the end of the whisker. Below Q1 is from this end of the box to that whisker. Okay, so is the data more spread out above Q3 or below Q1? Well, above Q3, it goes from 80 to about 82, 83. So that only covers about 2 to 3 years. Below Q1, it goes from 47 all the way up to 65. That covers almost 20 years. Definitely more spread out below Q1. That means there's a lot of years covered there, which tells me if there is so much spread right there, and that's only 25% of the data, not a lot of people tend to die between the ages of 47 and 65. Okay, you can get a lot of information from these box and whisker plots. All right, so then we have a similar thing, but instead we're not given a box and whisker plot, we're given a dot plot. But we can still figure out that same information. This is kind of going to be a throwback to what we did on Monday. So I have a dot plot that represents the hours slept by employees at the Valley Country Store. And you might be thinking, okay, well, how the heck am I supposed to figure out the quartiles for this? Well, here's what you're going to do. The dot plot counts for you, right? So we have 2 6s, 4 7s, and 3 8s. So I'm going to write, actually, I'm going to write it a little bit to the side over here. I'm going to write down my list. I have 2 6s, 4 7s, 3 8s. Okay, so I'm going to calculate Q1, Q2, and Q3, and then find the interquartile range. So I like to start with Q2. I like to find the middle of all the data. So if I find the middle, I'm using my fingers to cover up the outside numbers and work my way in. That's how I like to find the middle, the median, however you like to do it. It's up to you. So I'm covering them up. And since I have an odd number, I find that this right here is my median. That's going to be my Q2. So I'm going to type that into the box. My Q2 is 7. So now I'm going to use this list over here to find my Q1. And I'm going to use this list over here to find my Q3. I'm going to find the middle of all those numbers that are in the green box. And I'm going to find the middle of all those numbers that are in the pink box. The green box is going to tell me Q1. The pink box is going to tell me Q3. So if I find the middle right here, the median is going to be a battle between 6 and 7. So I have to find what's the middle of those two, and it's going to be 6.5. That's going to be my middle. And I'm going to make this box a wee bit bigger. Okay, so the middle right here, between that green box, is 6.5. That's my Q1. So then if I look for the middle of the pink box over here, I have to battle it out between these 2 8s. Halfway between 2 8s is still 8. So my middle, my Q3, is going to be 8. My interquartile range, that's taking Q3 minus Q1, so 8 minus 6.5, that's going to be 1.5. And now my last step is going to be to make a box and whisker plot for this data. So just like I did in my other assignment, I'm going to take these shapes over here to make the box and whisker plot, and I have all the numbers that are going to tell me how to make that. So my smallest number is a 6. So I'm going to take one of my dots. That's going to be my smallest number. In the other examples, they use like a straight up and down line to show you the end, but I use little dots. And it doesn't matter. Okay, so the biggest value that I have is an 8. So this is going to be the other end. One whisker is going to end here, the other whisker is going to end right there. My Q1, so I need to take the box. My Q1 needs to start at 6.5, halfway between right there. So my Q1 right here, 6.5. My Q2, that's where I'm going to put this. I'll put that in a second. My Q3 is going to be this right end of the box. That needs to be on 8. So this is not going to really show the whisker because those two are basically right on top of each other. The biggest value in the data and Q3 are the same. So that's not going to show the whisker. I need to put my median. My median is Q2, it's 7. I need to show the reader, it's right there at 7. And then my whisker, this is my whisker, is going to connect all my dots. But since basically, and I'm going to bring this to the front. See, the whisker only connects a little bit right here. There's no whisker showing because they're right on top of each other. But this is the box and whisker plot for this data set. Okay. The last thing is, what if you're given a double box and whisker plot? So a double box and whisker plot basically is just two separate whisker plots that share the same number line and are talking about the same type of data. So this one represents the test scores for your class versus the test scores in your friend's class. So it says to identify the shape of the distribution for these classes. So we're not going to really get into this into depth in this lesson. We're going to talk about it more in our upcoming lessons. But the shape of the distribution. This, if you look at your class's data, most of it is leaning over here on the right. If you look at your friend's data, it's pretty balanced. So it's kind of like the box part right here is pretty centered. The one for your class, the box is really pushed off to the right. When most of the data is on the right, it kind of has like a tail going to the left. So this is called a left skew. And I don't expect it to be super clear. We're going to get into it more, but that's just what it is. When most of the data is on the right and you have a tail going to the left, it's a left skew. If it were backwards, it would be a right skew if we had a tail going to the right. Since this one is pretty balanced, we're going to call it a normal distribution. And normal, not just like not weird. Normal is actually a statistical term. But that just means it's balanced. It's pretty centered. You don't have one tail that's longer than another, one whisker longer than another. It's balanced. Okay, and then the last question is, what scores were more spread out? And this one is it's not intended to be a trick question. Which of the datas have scores more spread out? Well, your class has scores from 67 to 100. Your friend's class has scores from 60 to 100. Who has numbers that are more spread out? Your friend, for sure. All right, so we made it to the end. This is kind of what we're looking at today. If you have any questions, just don't hesitate to reach out. Please, please, please. Have a great one.